All right, let's dive right in. Today, we're talking about something that honestly sounds like it's straight out of a movie, but it is very real. We're going to explore the incredible new science behind infrared contact lenses. Yeah, lenses that let you see the invisible.
So, let me start with a little puzzle for you. What if the key to seeing a part of the world that no human has ever seen before wasn't about looking harder, but about doing something, well, something totally unexpected?
I mean, really think about this question. What if you could actually see more by seeing less? It sounds completely backward, doesn't it? But believe it or not, this exact paradox is at the heart of a mind-blowing technological breakthrough.
So what's the answer to this riddle? It all comes down to a remarkable piece of tech. Let's talk about the infrared lens.
Yup, you heard that right. Researchers have actually developed what they call upconversion contact lenses. These are real, wearable lenses that allow the human eye to perceive near-infrared light, a slice of the light spectrum that is, for all of us, normally completely invisible.
But what's really amazing here is just how simple and elegant the whole thing is. The lenses have these special nanoparticles embedded right into them, and those particles are what detect the infrared light. And here's the kicker. They don't need any batteries, no wires, no clunky external gadgets. It's just physics, pure physics, doing its thing right on the surface of your eyeball. How cool is that?
Okay, so how does this pure physics actually pull it off? To really get how these lenses make the invisible visible, we need to zoom in a little bit on the science of light itself. The secret sauce here is a process called photon upconversion. Now, I know that sounds a little complicated, but the idea behind it is actually pretty straightforward. Basically, the nanoparticles in the lens act like tiny collectors. They absorb a bunch of low-energy, invisible infrared photons, and then essentially bundle them together and re-emit them as a single, higher-energy photon that our eyes can see. They're literally converting invisible light into visible light.
Here's a perfect way to think about it. It's like stacking energy until it's bright enough to see. You can imagine each individual infrared photon is like a whisper. It's too quiet on its own for our eyes to register. The nanoparticles are basically gathering all those whispers and combining them into one clear, loud word that we can finally perceive.
So let's walk through it step by step. First, that invisible near-infrared light enters your eye, just like any other light. Then, the nanoparticles in the lens grab onto those IR photons, and then, bam! Photon upconversion happens. This new converted light is now in the visible spectrum, so your retina can detect it. And finally, your brain just processes it like any other image it sees. It has no idea anything special just happened. It is so clever.
Okay, so we've got the science down. But that brings us right back to that bizarre paradox we started with. And this is where things get really, really weird.
And here it is, the absolute strangest part of all this. The lenses actually work better when your eyes are closed. I know, it sounds nuts, right? You put in these high-tech lenses to see something new, and the first thing you have to do is shut your eyes? Which brings us to the big question we're all thinking. Why on earth would blocking your vision actually help you see? It just seems to defy all logic, but the scientific reason is actually surprisingly simple.
Okay, let's break it down. With your eyes open, all the normal visible light around you creates a ton of visual noise. It's like static, and it just overwhelms the much fainter, much quieter signal that's being created by the infrared conversion. But, and this is the genius part, when you close your eyes, your eyelids become this perfect natural filter. They block out most of that noisy visible light, but the near-infrared light, it passes right through. So suddenly all that static is gone, and your brain gets a much cleaner, much purer infrared signal to look at.
And this is way, way more than just a neat science experiment. This technology has the potential to unlock a whole new world of vision, with some seriously important real-world applications.
I mean, just think about the possibilities. This could completely change medical imaging, letting doctors see tissues in ways they never could before. For security, you've got a form of night vision that's totally passive. No one would even know you're using it. It could even be a game changer for assistive technologies, fundamentally altering how humans interact with the entire spectrum of light.
So when you take a step back and look at the big picture, this isn't really about giving us some kind of unnatural ability. It's about unlocking a part of reality that's been there the whole time, hidden in plain sight.
This quote just sums it up perfectly. These contact lenses don't give you superpowers. They just let physics unlock a part of reality your eyes already missed. That infrared world was always all around us. We just never had the biological key to see it. Well, now we do.
And really, that's the big idea to walk away with. This technology just makes you wonder, right? If we can now see infrared light with a simple lens, what other invisible parts of our world are out there, just waiting for the right tool to finally be seen?